Good morning dear students. Today we are going to discuss 9th standard physics second unit motion. So it is very important lesson because in 10th standard we are going to learn about motion. That is the first lesson in 10th standard. As we all know very well about motion, we studied from smaller class 6th standard, 7th standard. We know very well what is the meaning of motion. Motion is nothing but change in the position of the object. Any object that changes their position is called as motion, right? So anything that you see in the universe, actually they are in motion because Earth is moving around the sun. So even though the object is at rest, that object also is moving because Earth is moving around the sun. Okay, so we are going to discuss about the motion. So in our surroundings we have seen different types of motion. For example, cars moving along the road. Cars moving along the road, trains along the tracks. At the same time, fan rotating in the ceiling, then playing swing. So for example, first one is called as this one type of motion. The second one, fan rotating in the ceiling, this is another type of motion. Playing swing is also another type of motion. So in this lesson we are going to discuss about the types of motions. Okay, what are the various types of motions and what is motion? First we are going to discuss about what is motion. For example, if you want to describe motion, we will describe the motion in the form of speed, velocity, acceleration, right? So this all depends. So speed, velocity and acceleration. In the form of speed, velocity, acceleration, we are going to discuss about the motion. At the same time, we are going to discuss about distance, displacement, what is uniform motion, what is non-uniform motion. All that we are going to discuss in this lesson. At the same time, we are going to see the graph. For example, uniform motion. What is the graph? How do we draw the graph for uniform motion? What is the non-uniform motion? What is the graph? And what are the equations of motion? All that we are going to discuss in this lesson. So before we go into the lesson, we should know what is the meaning of motion. Motion is nothing but change in the position of the object. So any object that you see in the universe, actually they are in motion because sun is rotating around the Earth is rotating around the sun. Okay, that is the reason. So next one is rest and motion. First topic that we are going to discuss, very important topic, rest and motion. As you know very well, what is called rest? Rest is nothing but object is not moving. For example, when I place a book on the table, unless otherwise I disturb, that object will never move. That is called as rest. So objects do not change their position. If not changing their position is called as rest. What is called as motion? Motion is nothing but object change their position, right, with respect to the surrounding. Object change their position with respect to the surrounding is called as motion. So we can see, as I told you, many types of motion. For example, flying bird, right, moving train, flying boy, all that is a type of motion. Rotating fan, mixing, everything, right? So all that is called as motion. So depends on the types. The motion, we have different types. First one is linear motion. What is called linear motion? Any object that moves in a straight line. If object moves in a straight line, that is called as linear motion. Linear is nothing but, for example, line, right? In the word we have line. So anything that is going in a line is called as, in a particular straight line is called as linear motion. So we have to remember, that is the easy way, that is linear is nothing but, in the word itself we have line, right? So line. So our object is moving in a straight line, that is called as linear motion. For example, as I told you, cars along the road, trains along the tracks, all that will go in a straight line, so that is called as linear motion. Second one is called as circular motion. It's very simple. Option along a circular path. Option along the circular path is called as circular motion. For example, rotating fan. Okay, so fan will rotate in a circular path, so that is called as circular motion. So anything that moves in a circular path, that is called as circular motion. Third one, very simple, that is oscillating motion. We can see and we have played, right? So to and fro motion of object at regular interval of time. That you have to remember. To and fro motion of the object. For example, swing. When we play swing, it will go and come back, right? That is called as to and fro motion. To and fro motion is nothing but going front and backwards at regular interval of time. For example, time, pendulum. Pendulum moves front and back, right? That's called as to and fro motion at regular interval of time. So every one circle, which means circular path, which means what is it called, to and fro motion, we have to have that time. For example, 1 minute has taken to go and come. That second motion also, it will take 1 minute to go and come. That's called as oscillatory motion. Oscillatory motion is nothing but to and fro motion of the object at regular interval of time. It's very, very important. Regular interval of time. So it will take time the regular, which means it will take equal time at the equal distance. That is the way we have to explain, right? So then finally we are going to see that is called as random motion. Random motion is nothing but it's very simple. Motion has no specific path. For example, when we are playing in the ground, football, we will not have any path, which means that this particular path we have to know. That's not described, right? So the motion has no path, specific path. So we can move where that ball goes. So any direction we can move. That is called as random motion. For example, flying kite. When we fly that kite, it will go in different direction, right? That is called as random motion. And another example, playing football is very simple. We can see in the ground, right? During break time, we can see in the ground boys moving different directions towards the canteen, right? So this is also the best example for random motion. So we have 4 types in this class. First one is linear motion, object moving in a straight line. Second one, circular motion, object moving in a circular path. Oscillatory motion, to and fro motion of the object. And random motion, object has no specific path, right? There is no specific direction. They can move in any direction. Is called as random motion. So example for this, flying kite, playing football, right? So this is very, very important. Next we are going to discuss about uniform motion and non-uniform motion.
Ben wants to move this table from point A to point B. What will he do? Yes, he will push it in the direction of point B. You see that as he pushes the table, it starts moving. Anything around us that moves, we say that it's in motion. So this table is in motion. And since Ben is also moving along with the table, he is also in motion. In our day-to-day life, we see various things moving around us. Simple examples that I can give are vehicles moving on the road, people walking across streets, birds flying in the sky, and so on. Do you know that the Earth and the other planets also undergo motion? Yes, they are revolving around the sun. You can give me thousands of such examples of motion. But what if I ask you to tell me the definition of motion? How can we define something as intuitive as motion of a body? Well, for that, we need to look at what exactly happens to a body when it's in motion. Let's say this vehicle moves from point A to point B. You see that as it's moving towards B, its position in space changes with time. Initially it was here, then here, and now after some time it's here. Notice what's changing. The position of the object and the time too, which is changing anyway. The change in position of a body with time is what we call motion in simple words. Whenever there's a change in position of a body, we say it's either undergoing motion or has undergone motion. Let's discuss about the different types of motion now. The simplest type of motion is called the rectilinear motion. Notice that there is a word line in there. So we define this type of motion as a motion in a straight line. Yes, rectilinear motion is nothing but motion in a straight line. So if an object is moving along this straight line path, we say that it's performing rectilinear motion. For example, when a car is moving in a straight line on a straight road, it's performing rectilinear motion. There is one more thing that I want to discuss with you in this video. Assume you're on a railway platform watching the train pass by. You are at rest. For you, both the train as well as the passengers sitting inside are in motion. But will the people sitting inside the train say the same about the other passengers in the train? For a person sitting inside, the people in the train are not moving. They are at rest. So for the observer at rest on the platform, the people inside the train are moving, but for the person sitting inside, they are at rest. What does this tell us? This means that the motion of any object is relative to the observer. For different observers, the motion may be different. We will learn more about this in higher grades. In this video, we understood the definition of motion. We also discussed one of the types of motion called rectilinear motion. In the next video, we will see a few other types of motion. In the previous video, we studied what motion is. We also saw one type of motion called the rectilinear motion. It's nothing but straight line motion. In this type of motion, the path of a moving object is a straight line. But what if the path of a moving object is circular? Yes, you guessed it correctly. If an object is moving in circles, it's undergoing circular motion. More accurately, it's defined as the motion of an object along the circumference of a circle. The circumference of a circle is the length of this boundary which is curved. So if an object is moving along the circumference of a circle, we say it's undergoing circular motion. Can you give me any real-life examples in which objects execute this type of motion? What about the satellites orbiting the Earth? Yes, a satellite orbiting at a certain height is also undergoing circular motion. What other examples of circular motion can you think of? Take a small object and tie it to one end of a rope. Take the other end of the rope in your hand and whirl it around in circles. You see that the object is performing circular motion. Notice that the distance of the stone from your hand is always the same. What about the moving fan? Is it also undergoing circular motion? First, let's only consider the motion of a point on one of its blades. If we switch on the fan, we will see the point moving in circles. So we can say that the blades of the fan are also undergoing circular motion. Now what if I take the fan as a one single object? Can I say that the fan as a whole is moving in circles? No, that would be incorrect. The fan as a whole is not going anywhere. The entire fan is not moving along the circumference of a circle. But which motion is it performing then? The fan is undergoing rotational motion. Before actually defining this type of motion, let's try to understand it first. This rod here is called the axle, and the entire fan is spinning around this axle. Or you can also say that the entire fan is spinning around this fixed line. This type of motion is what we call rotational motion. Now we will define it in simple words. A body is said to be performing rotational motion if it's spinning around some fixed line. And the fixed line is also called axis of rotation. What other examples of rotational motion can you think of? What about a rotating wheel? We use the word rotating because it's performing rotational motion. What is axis of rotation in this case? Yes, it lies on the axle of the wheel. So the wheel is also undergoing rotational motion about this fixed line. Other examples of this type of motion can be the earth spinning around its axis and a spinning top. But wait a moment. Let's go back to our example we discussed earlier. When this object was whirled around in circles, we said that it was performing circular motion. But here, if we take this line as our axis of rotation, then we can also say that the object is performing rotational motion around this fixed line. So what is the motion of this object? Circular or rotational? What exactly is the difference between the rotational and the circular motion? In all the examples of rotational motion that we saw, the axis of rotation is a part of the object. It is going through the object. But in this case, the axis of rotation is not passing through the object. It's totally separate from the object. Hence, we don't call this motion as rotational motion. This is circular motion and not rotational. So this is the difference between circular and rotational motion. If a body moves along the circumference of a circle, we say that it's performing circular motion. And if the body is spinning around the fixed line called the axis of rotation, and if that axis of rotation passes through the body, we say that it's undergoing rotational motion. In the next video, we will see one more type of motion.
Okay, now we are going to discuss about uniform motion and non-uniform motion. It's very simple topic as you have learned about motion, right? What is motion? Anything that changes their position with respect to their surrounding is called as motion, that we have seen in the last session, and we have seen the various types of motion, right? Now we are going to discuss about uniform motion and non-uniform motion. For example, a car. You take one car that has taken time to travel, right, and covered distance. So time, that is equal interval that we have to take, that is 0, 5, 10, 15, 20, that is in minutes. So the time interval between one to another, that is 5 minutes, right? So equal interval of time, that is 5 minutes. So here it has taken 5 minutes, then the distance between these two 5 minutes, distance between these two, that is 5 minutes. So equal interval of time. Let us see the distance, how much it is covered. The distance between these two, 500 meter, distance between these two, that is 500 meter. Here 500 meter, here also 500 meter. So this is called as uniform motion. Why this is called as uniform motion? That is because anything that covers equal interval of time and equal distance. If the distance, any car or anything that covers equal distances in equal interval of time. For 500 meters has to be covered within 5 minutes. So another 500 meters should be covered with another 5 minutes. So it will go on, right? The time and the distance will not change. So the time interval and the distance covered should be same. So 5 minutes they are supposed to cover 5 meters. So when you draw a graph, for example, time and between time and distance, the time graph will be going in a straight line, right? For example, this is time, distance. If you plot the graph, it will go in a straight line. That is simple. So uniform motion, what you have to remember, that is nothing but equal distance in equal interval of time. So it's very important 2 mark question. So anything that covers equal distance in equal interval of time, that is called uniform motion. So just opposite, non-uniform motion is very simple, as you know about uniform motion, right? So non-uniform motion, just opposite, anything that covers unequal distance in equal interval of time. Unequal distance in equal interval of time, that is called as non-uniform motion. It's very simple. For example, time that we have taken as normal, as we have taken the first case, that is 0, 5 minutes, 10 minutes, 15 minutes and 20 minutes. The time gap between these two is similar, right? So everything that is 5 minutes gap, and the distance between the distance covered, let us check. This is 500 meter, this 250 meter, this is 150 meter, this is 200 meter. So we can see the changes, right? So distance covered is not equal. If the distance covered is not equal, that is called as non-uniform motion. How we have to say in definition, that is non-uniform, anything that covers unequal distances in equal interval of time is called as non-uniform motion. So this is very simple. What is uniform motion? What is non-uniform motion? Uniform motion covers distance, equal distance in equal interval of time. This covers unequal distance and equal interval of times. So unequal distance and equal interval of time is called as non-uniform motion.
He is training to run a marathon. He's covering a distance of 3 meters every second. So the distance he covers each second is constant at 3 meters, and he maintains the pace for a certain period of time. This is what we describe as uniform motion. So in case of uniform motion, If we know the constant distance covered for each time period, along with the total time duration of motion, we can calculate the total distance covered. What do I mean by this? If I said this man ran at a uniform speed of 3 meters per second for a minute, can you tell me how much distance he covered? A minute is 60 seconds. Each second the runner covered 3 meters. So 60 times 3 is 180. Don't forget the units. The answer would be 180 meters. Similarly, we can calculate how much distance he will cover in 10 minutes, 20 minutes, or even an hour. That's because he's maintaining a constant speed. Uniform motion. Distance traveled by an object in unit time is called speed. It's distance per unit time. So what will be the units? Can you guess? The SI unit of speed is meters per second. Quite often you will also see speed denoted in centimeters per second, miles per hour, or kilometers per hour, but the standard unit remains meters per second. We observe this gentleman here running at a constant speed of 3 meters per second. He is definitely a thorough professional, but in our day-to-day lives, it is very rare to see uniform motion, whether it is walking or running, riding a bicycle, or being in a car. We walk briskly for a while and then get tired and our pace slows down. Most of the times, we're not even in control of the speed. There are external factors like traffic, traffic lights, busy crowded areas, and the like. The bicycle ride is fast at times and slow at other times depending on which area of the school you're in. Same goes for driving a car. Such cases are examples of non-uniform motion. The speed of the object is not constant. So hang on, can we calculate speed for non-uniform motion? As the motion is not uniform, it will have different speeds at different points in time. When it comes to non-uniform motion, we refer to the rate of motion in terms of average speed. Yes, that's right, average speed. So how can we derive average speed? This boy leaves point A to reach point B, which is 60 meters away from A. And he has been walking at varied rates of motion, basically non-uniform motion. He takes 60 seconds to reach point B. So he has covered 60 meters in 60 seconds. What is his speed? Can you tell? You'd have probably guessed. We look at the total distance covered and divide it by the time taken to arrive upon the speed. So this boy has covered 60 meters in 60 seconds. So 60 divided by 60 equals 1 meter per second. That's his average speed over this distance. It is as simple as that. But you have to be careful with the units used. What you have to get into the habit right away and stick to standard units. If you understand it well right now, it will help avoid silly mistakes in the future. If I had said this boy has covered 60 meters in 1 minute, you should not make the mistake of writing 60 divided by 1 equals 60 and say he's traveling at a speed of 60 meters per second. That's as fast as a bike. The best way, normally, would be to convert to standard units. So let's convert 120 meters in a minute into meters per second. Meters is already in standard form. As the standard form of speed is meters per second, we need to convert this minute into seconds. 1 minute equals 60 seconds. This would mean distance covered was 120 meters in 60 seconds. So what was the distance covered in 1 second? Correct, 2 meters per second. So make sure to stick to standard units for now and always mention the units being used. Average speed is a good way to know when you will reach a certain destination in traffic. There will be times when you will be driving fast and other times you will be stuck. Hold on. At every instance, you are moving at some speed. It may be 0 meters per second when you're stuck, or 2 meters per second, or even 4 meters per second. Do you know what the speed at each instant is called? It is called instantaneous speed. We move.
Discuss about distance and displacement. Consider object A is starting from a point A and reaches to point B. There are two types of pathway. So one is traveling in the direction and another one is going in a straight line. There are two paths. Let us discuss this diagram and we will come to know which is called as distance and which is called as displacement. It is very simple actually. For example, total length of the path traveled by the body. Total length of the path traveled by the body A to B is called as distance. The total distance, that is called as distance. The total length, so how much total, the length is more, that is called as distance. For example, the object A moves from here, it will go in this direction and reaches B, that is called as distance. The length of the path, the total length of the path is called as distance. What is called displacement is nothing but the object moves in a straight line, which means the shortest distance between one point to another point is called as displacement. So distance and displacement. Distance is nothing but total length of the path. Displacement is nothing but shortest distance between 2 points. What is the difference between these two is nothing but distance will not speak about the direction. I'll just start from one point and I have to reach that point. I can go in any direction, that is called as distance. That will not speak about the direction. We can select any direction that you like, right? Displacement is not like that. That is the shortest distance between. I just want to go that particular point. So what is the shortest distance between one point to another point? That is called as displacement. So what we have to do? I have to move towards the particular direction. So I have to move towards this direction, towards this direction. If I say about the direction, that is called as displacement. So distance will not speak about the direction. Displacement will surely show the direction. So this is the direction we have to take. For example, how we have to define that is nothing but length, actual length of the path traveled by a moving body irrespective of a direction. So we will not worry about the direction. I will just go here and there and I will reach the final distance, final point, that is called as distance. Actually this is called as scalar quantity. Why distance is called as scalar quantity? Because it will not show the direction. Okay, the quantity, that only it will show the value of the distance, right? The actual length will be shown, right? So that is called as scalar quantity. SI unit is meter. SI unit is a meter. Okay, so actual length of the path traveled by moving body irrespective of the direction is called as distance. Displacement is very simple. I can say the shortest distance between 2 points in a particular direction. So the shortest distance between 2 points in a particular direction is called as displacement. That's the difference between these two. But displacement will show both direction and the quantities, right? The values. So 10 meter, 20 meter, right? So that is called as displacement, right? So displacement will show the direction. So this is called as vector quantity and SI unit of displacement is meter. Okay. So distance and displacement. Let's look at the diagram. Okay. So I just start from school to house. Okay. There are 3 ways I can go, but which is called as distance, which is called as displacement. Yes. As you all think. So AB is the distance between A and B is the shortest distance. So this is called as displacement. It's called as displacement because point A to point B, the shortest distance in a particular direction we can move, that is called as displacement. So other 2 directions are called as distance. So this is the difference between distance and displacement. Distance is the actual path, length of the path. that will not show the direction. So I can go in any direction. I can go in any direction and I will reach the particular place. That's it. That is distance. The actual length of the path. That is called distance. The shortest distance between these 2 points is called as displacement. So distance is called as scalar quantity. Displacement is called as vector quantity.
From one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered would be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these 2 towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance traveled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and traveling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same...
Next topic is very important, that is speed, velocity and acceleration. What is speed, what is velocity and what is acceleration that we are going to learn. It's very important because this again you are going to study in 10th standard. Okay, so you have to remember only this formula, at least this formula and unit you have to remember. It's very simple actually. Speed, velocity and acceleration. Okay, what is called speed? Speed actually is nothing but rate of change of distance. Rate of change of distance. What is called as rate of change of distance is nothing but distance will change with respect to time. Rate is nothing but with respect to time. Okay, so when time changes, distance will change. Right? That is called as rate of change of distance. That is called as speed. So how can we write a mathematical form, that is speed is equal to distance by time. That's why we have rate of change of distance. So that can be written as distance by time. Distance can be measured, the unit that is meter, time unit is second. I can write meter per second or meter second power minus 1. So speed is nothing but rate of change of distance, right? So when you know the formula and when you know the distance and the time, for example, distance is 500 meter and the time taken is 50 seconds, I can measure the speed, right? Just cancel. How much? 10 meter per second, right? So this is how we have to calculate the speed. Is very simple. Second, velocity. Velocity is nothing but rate of change of displacement. Rate of change of displacement. If there is any change in the displacement with respect to time is called as velocity. So velocity is equal to displacement by time. Displacement, as you know, already I told you in the before session, that is we can measure the unit, that is meter, and time can be measured with the help of second. So meter per second, or this can be written as meter second power minus 1. So rate of change of displacement is called as velocity. It's very simple topic. And third topic is very important. Again you are going to see in 10th standard many places. Okay. So acceleration, how can we define this is rate of change of velocity. Rate of change of velocity is called as acceleration. What is called as rate of change of velocity is nothing but whenever there is change in the velocity with respect to time is called as acceleration. So how can we write that acceleration is nothing but change in velocity by time. Change in velocity, how will we measure that change in velocity is nothing but final, anything that we see that there is a change, how can we measure? We have to subtract from final to initial, right? Same way here also, change in velocity is nothing but final velocity minus initial velocity. Final velocity minus initial velocity. Actually, its unit is meter second power minus 2. Okay, the unit is meter second power minus 2. How it is? Because velocity unit you know very well, that is meter per second, and we have another 1 second. So meter second power minus 2. Okay, change in velocity by time, that is final velocity minus initial velocity by time. Final velocity we have to give the symbol, very important. Again, that's what I am telling you. This one we are going to see in 10th standard first lesson. So there it will be easy when you learn properly here. Final velocity symbol is V, initial velocity symbol is U, right? So acceleration symbol A, that is change in velocity by time. Change in velocity can be written final velocity minus initial velocity by time. Initial velocity, that is U, final velocity, that is V. So V minus U by T. Okay, so here these symbols are very important. Final velocity V, initial velocity U by time T, right? So acceleration, the symbol A is equal to V minus U by T. That's all. This is very important. Acceleration is nothing but rate of change of velocity is called as acceleration. So speed is distance by time, velocity is displacement by time, acceleration is equal to change in velocity by time. That could be written as A is equal to V minus U by T. This formula again we will use in the equations of motion. Okay, so there are two cases in the acceleration. The first case, final velocity is greater than initial velocity, right? Final velocity is greater than the initial velocity. There is no problem. Velocity increases with the time. So velocity increases with the time is called as acceleration is positive. So it is going in a particular speed. So there is no problem in the acceleration, right? When final velocity is more than the initial velocity, there is no change in the acceleration. So acceleration is going smooth, which means that is in positive. So if there is a change, okay, final velocity is less than initial velocity. This is final velocity V, initial velocity U. Final velocity is less than initial velocity. Velocity decreases with time. That is called as negative acceleration or deceleration or retardation, right? So we will call it as deceleration. So negative acceleration, or we can call it as deceleration, right? So here we are going to discuss speed, velocity, acceleration, speed, distance by time, unit meter second power minus 1. and velocity, displacement by time, meter per second. Again, the acceleration is rate of change of velocity, that is change in velocity by time. Change in velocity should be written as final velocity minus initial velocity by time. Final velocity symbol is v, initial velocity is u, v minus u by t. So a is equal to v minus u by t. A is nothing but acceleration, v final velocity, u initial velocity, and t is the time. There are two cases in the acceleration. When final velocity increases, there is no problem, that is called as positive acceleration. When final velocity decreases, that is called as negative acceleration, that is called deceleration.
How do we know whether an object in motion is traveling faster or slower than another object? Consider two objects, Object 1 and Object 2, both moving along the same path. Just by looking at their motion, can you tell me which one of them is moving faster? Clearly, this one is moving faster. In comparison to Object 1, Object 2 keeps lagging behind. Hence, we say that the speed of Object 1 is more than the speed of Object 2. Speed is that physical quantity which tells us how fast something is moving. How do we define it? In order to know the speed of an object, there are just two things we need to know. First, the distance traveled by an object in motion, and second, the time it takes to complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion it's undergoing? Since it's moving in a straight line, it's in a rectilinear motion. Suppose the time it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one. It's also moving in a straight line path adjacent to the first one. The time taken by this red car to cover the same length of the road is 40 seconds. The blue car covered the path length in 30 seconds, while the red car covered the same path length in 40 seconds. Which one of them was moving with greater speed? By intuition, we can say that the blue-colored car was traveling at a greater speed than the red one. Why? Because the blue car covered the same distance in lesser time. Let the length of this path be 420 meters. This path length is nothing but the distance that the car travels in a given amount of time. Now for each object, if we take the ratio of the total distance covered and the time required to cover that distance, we will get this. This ratio is called the speed of the object. Yes, speed is distance over time. Since this ratio is greater than this one, it means that the blue car traveled with greater speed. Let's bring in a third car which covers the same distance in 20 seconds. So what is its speed then? The speed is 420 meters over 20 seconds, which will give us 21 meters per second. And you can see that this ratio is the greatest of all. Now I want you to look at the units. Meters per second is one of the units of speed. There are many such units of speed that you must be aware of. For example, kilometers per hour, miles per hour, feet per minute, and so on. We will discuss more about these units in our future videos. Let's discuss something interesting now. Look at the example of one of the cars. Say car A. The only information I gave you was that it covers 420 meters in 30 seconds. That gave us the speed as 14 meters per second. I want you to answer the next question I'm asking you. In this example, can we say that the speed of the car A is constant throughout this distance? Are we saying that the car is covering 14 meters every second throughout the path? No, that's not what we're implying. Because maybe the car is moving at a really fast speed initially and then it slows down in the middle and then stops and then again speeds up. So this speed does not imply that the speed is constant at 14 meters per second throughout. So what is the speed then? The speed we calculated here is the average speed. In fact, in all the three examples, it was average speed. How do we define it? Average speed is defined as the total distance traveled by an object divided by the total time taken. We will continue to discuss more about average speed in our next video. We have seen What if I tell you that I traveled north at a speed of 50 meters per second for 1 minute? Would you be able to tell me where I landed up? Yes, you would know I have covered a total distance of 3,000 meters and landed up at this point. Velocity is speed with direction of motion. As such, velocity is direction aware. So when you mention velocity, you must keep track of direction. Something like the car moved south at 55 miles per hour. If you do not mention the direction and just say the car moved at 55 miles per hour, you're not stating the velocity anymore. What you are stating is the speed. What do you think is the unit of measurement for velocity? The unit of measurement for velocity, just like speed, is meters per second. Now you might ask, why meters per second? The cars we drive indicate speed in miles per hour or kilometers per hour. So why is the unit for velocity meters per second? The established SI unit of measurement for velocity is meters per second. And SI stands for International System of Units. This helps everyone in the world adhere to one common style of measurement. Imagine the confusion created with different measures like miles and kilometers, gallons and liters, US gallons and imperial gallons, etc. Incidentally, speed and velocity are both measured in meters per second. But do you remember a car that moves rapidly to gain speed? We get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration.